All right, we'll go ahead and get started. And this is not my favorite part of trig, but you have to get through it. And actually, this is better than other parts, but you got to go through the trig identities. And the trig identities basically are for manipulation purposes. In other words, to be able to take something and manipulate it into another equation. Your first identities are as follows. Let's write these down. Yeah, just come on in whenever, that's fine. As long as you're here, that's fine. Nope. Reciprocal identities. We're in the 4th week. Yeah, you've had 4 weeks to do the homework.
No, you're supposed to go home.
Oh, okay, 3 weeks to do the homework.
Can you just give us 2 days? Hubert, I've never asked you.
Oh, no. Just writing these down. These are your identities. And you're here, so go ahead and start this. Now, all the identity section is rewriting. They're going to give you one identity, and you need to break it up and rewrite it and make it look like another identity. That's all this chapter is. There's not much calculating. Y'all remember the postulates and theorems in geometry? Okay, you had to memorize them and you had to finagle with them, and so that's kind of like this chapter. Now, all of these are important. So if I tell you to memorize anything, these are the ones you need to memorize. I don't usually worry about all 6 of the reciprocal identities, but those 3 are usually pretty common. And these, you cannot forget these 2. The quotient identities, you cannot forget those. Because one rule in trig and calculus is, whenever you have an identity or an equation, try to put everything in the terms of sine and what? Cosine. That's the general rule. So if you don't know those 2 identities, then you pretty much forget it. And it's easy to remember. It's easy to remember because they're the flip-flops of each other. The tangent is the sine over the cosine. The cotangent flips. All right, so that's your first set of identities. There's your second set. Now, which one is most important? These up here, the Pythagorean. And you really don't have to worry about the negative number identities because you could do those algebraically. You know that the sine is an odd function, so it's negative. Cosine is not an odd function, so it's going to be positive. So you can, not a big deal on those. I tell students, make sure you know the Pythagorean. Now, when you're talking about the Pythagorean, make sure you can solve. Cosine squared equals 1 minus sine. Sine squared is equal to 1 minus cosine. Tangent is equal to secant squared minus 1. Cotangent is equal to cosecant minus 1. Make sure that you can solve those algebraically for one or the other. One is equal to the secant plus secant minus the tangent. 1 is equal to the cosecant squared minus the cotangent. I'm trying to figure out where this came from. Whenever you do the PowerPoint, it puts the whiteboard down here. That's nice. Oh, I like that. I learned that in training. Now I don't know what to do. There we go. All right, and this is an example. Express cosine in terms of tangent. Well, if you go back, let's see if I can go back on this thing. Right here, we're dealing with cosine, and we can put, and I need to do something. Let me try this. But I'm not going to be able to do it. Hold on just a second. We go here, make this bigger, do this, do this. Do that. Go to the next one. Pull these in for you. And you. These two. I'll be able to do it though. There. There's what I want. There. I'm trying to learn this PowerPoint system. So. All right, go ahead and I'm be able to plug it in. I have to change it to a whiteboard. I don't know if I can do that from here. Nope. No, it's transparency again. Now, how can we rewrite the cosine? Well, cosine is 1 over the secant, right? Cosine, sine, cosine, tangent, cotangent, secant, cosecant. Cosine is 1 over the secant. Secant can be written in terms of the tangent, but how do we know what to do? Well, since I can't draw it, I'll just write here. Since secant is related to both tangent and cosine by identities, start with tangent 1, blah, blah, blah. So the cosine of x can be rewritten as 1 over the secant. That's where that comes from. So that's where the 1 over the secant comes from. So 1 over the secant and cosine of x is equal to 1, positive or negative 1 over tangent, and this is another identity. Okay? So the cosine is equal to, and that's where they give the square root here and the square root here. Okay? And cosine, I wouldn't have shown it like that. I would have done, what I would have done, this is what I would have done. You could easily, I gotta get rid of that color, I'm sorry, that red driving me crazy. Cosine is equal to 1 over the secant. Okay, that's what I would have done. Oops. Okay. Why is the eraser? Okay. I would have said cosine of x is equal to 1 over the secant of x. That's what I would have done. And then I would have done square both sides. Cosine squared of x is equal to 1 squared over secant squared of x. That's the way I would have done it. And then, what is 1 over secant squared? Well, you could rewrite secant squared as tangent, because it says right in terms of tangent. And secant squared is equal to this. So cosine squared of x is equal to 1 over, what is secant? Tangent squared plus 1. Squared plus 1. And how do I get cosine that? Cosine of x is equal to the square root of 1 over tangent squared x plus 1. And what is the square root of 1? So cosine of x is equal to 1 over the square root of tangent squared of x plus 1. That's the way I would have shown it. Okay? In other words, using the reciprocal identity, cosine of x is equal to 1 over secant. That's what I would have done first. And then I would have squared both sides, because this is not worth anything unless you square it. So then you square both sides, you get this, and then you get cosine is equal to this, but secant, again, is this, and you want tangent. So that's how I got that. Who had a question? And that, yes. Yeah, you don't want to mess with that. Unless you just like punishment. That's what this unit, that's all you're doing. The whole second unit is all manipulation of identities. If you like, puzzles, you'll like this section, because that's what you're going to be doing. You're going to be taking a long identity, and you're going to confirm it by making it look like another identity. Then you're going to probably suck at this. Okay? Need to say something encouraging. Is that what you wanted? Okay, you want truth on it. What? Oh, okay. Well, what's a high endage? I thought that was some word you learned in your history class with your research person that does all his research in history. What is that, history class or what class? What's happening in there? You failing or what?
No, I don't know.
They did go for the punishment, and there it is.
Have you seen that video where the guy sits there in prison and she says,
No, but I got that sticker on the back of my truck. Really? Yep. Hillary for prison, 2016. Yes. Well, what they did is they took and they multiplied by the square root of tangent plus 1 on top and bottom, and they rationalized the denominator. So I'll take either. But this, you'll see later on, is another identity. Okay? So that is your first identity. You just confirmed it. Okay? You rewrote cosine in terms of what? Tangent. Feel good about yourself. All right, try this one. Write tan of theta plus cotan of theta in terms of sine and cosine. I really wish I could bring in those rules. I can't. It bothers me. Because you need them. tan plus cotangent. Sine and cosine. I'm going to get out of this right quick. I'm going to go in here. I'm going to put it there. Let's calculus. And, yep. And somebody tell me what the problem is so I don't forget it. Tan theta plus, okay, tan theta has what? Has sine, handy dandy. Now I'm telling you, if you don't learn these, they're going to follow you into calculus. So I'm just telling you. So your history teachers, it's not a good thing, huh? What class you said it was? Huh? Yeah. So we could rewrite the tan as what? Sine or cosine. So, and we can write cotangent as cosine over sine. And you're done, right?
Yeah.
No. Find a common what? Denominator. Which would be cosine sine or sine cosine. Cosine will go in there, sine times sine is what? Plus sine will go in cosine, sine cosine times, look up there, sine squared plus cosine squared. What is that? 1. Manipulation and rewriting. So let's check it. Look at there. This is a miracle. Manipulation and rewriting. Manipulation and rewriting. And that's how you learn these things. This is where we verify. This is where you take one side and make it look like the other side. Or the right side and make it look like the left side. Yeah, you better. Especially number 2. Try to rewrite the complicated side of the equation so that it's identical to the easier side. And that's a general rule when you're verifying identities. It is often helpful to rewrite any term in terms of what? Sine and cosine. Remember your shortcuts. A squared plus B squared is equal to C squared. Well, what is this right here? Shortcut number what? Shortcut number 1, A plus B quantity squared is equal to A squared plus 2AB plus B squared. The conjugate also helps in these problems. The conjugate of 1 plus the sine of x will give you what? 1 minus the sine of x, which will give you 1 minus sine squared of x, which will give you cosine squared. So mostly everything you do in these things, you need to try to get it to sine and cosine, somehow, somewhat. They're probably going to give us an example next anyway. So go ahead and look at that one, and I'll put it back in just a second. Cotangent x plus 1 is equal to cosecant, parentheses, cosine of sine plus 1, or sine plus sine, sorry. I would deal with the side on the right. That's what I would deal with. I can't snip this, so I'll have to get out and snip it. Let me go ahead and give you the previous page. There you go. Finish writing that. Some of y'all are still writing when I switch over. And it's in your book also. Everybody got it? Or close to it? All right, now work on that next problem and see if you can get the right side to look like the left side. Now there's two things going on right here. One is they're trying to get you to learn how to use the identities. That's one. The second thing they're trying to get you to do is manipulate equations, which is all of Calc 1, 2, and 3. So this is where you start learning how to rewrite and manipulate equations. So when you get in Calc 1, 2, and 3, you are used to rewriting things. Because when you go into engineering, or you go into the biological sciences, or the sciences, or the maths, or whatever, the first thing you do when you get to a problem, whether it be in real life, whether it be in math, whether it be in sciences, is what? Break it down. Break it down, rewrite it, manipulate it. Or in the real world, you try to find a way to find out what the problem is, break it down into parts, and then you reconstruct or figure out another way that the problem can be solved. Now, the reason you go through Calc 1, 2, and 3 is so when you get out of Calc 1, 2, and 3, you know how to manipulate a problem and solve it. Nobody is going to walk up to you and ask you what the derivative of the cosecant squared of x plus 1 is after you get out of college. Nobody. But as far as manipulation of problems, ask a Calc 3 major to manipulate a problem versus a person that has learned how to do history. The person who learned how to do history is not going to be able to manipulate that problem like a person who's been through first, second, third calc. Okay, so the problem is, this one right here, for those who get to write it down, first thing I'm going to do is change that cosecant. Try to find anything that I can change that cosecant. Why? Because this is in terms of what? Cosine what? Cosine and sine. So, oh, my arrow's not up there. I don't know where my arrow is. Okay, it's disappeared. I thought I was pointing at it. The cosecant is what I need to change. Now, the cosecant is equal to 1 over what? Okay, then do that. Change it to 1 over sine. So you take your handy dandy. You take your handy dandy. And I can't write it. Oh, well, why is it on here, but it's not? Y'all don't see this little pin thing. Oh, I know. Hold on. Let me get rid of this digit. Is it up there now? Okay. This is training, y'all. I'm trying to train. Because I ain't had any training. So now that thing was up there and I was using it a while ago. So that means go away. There it is. Let me do this. And do this. Okay. I'm sorry. You just got to realize somebody hadn't had any training on the project or orbital. It's kind of a monumental moment whenever I learn something. So equals 1 over sine of x times cosine of x plus the sine of x. Now what? Distribute. You get cosine of x over sine of x plus sine of x over sine of x. And cosine over sine is cotangent plus, and check to make sure. So this is kind of your beginning of manipulation of equations. Can I do what? Yeah, be glad to. First of all, I focused on the cosecant. The reason I focused on the cosecant, oh my, I even got highlighted on this thing. The reason I focused on the cosecant is because of your second rule that you wrote down. What's your second rule of manipulation of identities? to keep everything in terms of what? Sine and cosine. And while I'm focusing on the cosecant, I'm also thinking, well, the cosecant is the opposite of the sine, so it's the reciprocal identity in the sine. Remember, you're remembering these guys right here too. The reason you don't have to remember one of the reasons you don't have to remember the reciprocal identities is because you remember these guys: sine, cosine, tangent, cotangent, secant, and cosecant. What's the sine? The sine equals 1 over the cosecant. What's the cosecant? 1 over the sine. The secant is equal to 1 over the cosine. The cosine is equal to 1 over the secant. The cotangent is equal to 1 over the tangent. The tangent is equal to 1 over the cotangent. So you don't have to remember the reciprocal identities. You just have to remember this that we started off a long time ago. The stereotype identities, you don't have to remember them too much because you remember that each one of them is something squared plus something squared is equal to 1. After you learn those 3 identities, then you just have to remember how to solve for whatever you need. And then the other identities, the 2 identities that are important are the tangent and the cotangent. The tangent is equal to sine over the cosine. The cotangent is equal to the reciprocal, which is cosine over the sine. So there's not a lot of memorization if you remember these guys right here. So I focused on this guy because it was a stick in the mud. These are not sticks in the mud. These are, hey, I don't want to mess with them if it ain't broke. And when you see cosine and sine, you most of the time gonna leave it alone. Does that help? And then after I did that, I switched this to, because I know that cosecant is equal to 1 over the sine, so I changed that, and that killed number 1 and number 2. I rewrote it in terms of sine, and I used one of the identities. I distributed it. Yep. This is the reciprocal identity for cotangent. And anything over itself is what? And that is what you started with right here. That's what you're trying to do. You're trying to make this side look like this side. What about making this side look like this side? You could. What is the cotangent? No, sorry, 1 over the. You could write it 2 ways. The cotangent is 1 over the tangent, but we don't like that because we like to put everything in terms of sine over cosine. So, with cotangent is equal to the cosine over the sine, right? So I'm going to rewrite that as help us. Yeah, you can factor out. Yeah, you could do that. But you would find it more difficult to do it this way and get the right side than to do it this way and get the left side. That's why they tell you to focus first on the most difficult. And how do I know it's most difficult? Because of the second rule. The second rule says everything in terms of sine and cosine. So if you look at the left-hand side and the right-hand side, which one is in terms of cosine and sine? The one on the right-hand side. But it has 3 or 4 terms. This one only has what? 2 terms. It has cotangent of x and then 1. So this one has less terms, so it's in the similar, it's in the simpler mode. And plus that one looks a whole lot more messed up than this. Okay? Does that help? All right, let's move on. If I can figure out how to work this thing. Oh, there's the answer. All right, try that one. Now I can tell you right now, the simplest side looks like what? The right side is simpler, yes, because it's in terms of squares and it's not a lot of fractions. I wonder if I can move this. Uh-oh. Something happened. It's supposed to be showing. So the most complicated way, I don't know, you could, both of them's complicated. Something's wrong with this thing. I presume. If you wanted to go with the left-hand side, you could do tangent of t over sine t cosine t minus cotangent of t over sine cosine t. I'm working with the left-hand side. I hate those t's. I wish they were the sixes. So you could set up like that. Yeah, you could do that. And I'm trying to think, maybe bring the sine cosine up. That's what I'm trying to think of. But yeah. This. Yeah. Oh. I messed something up. Okay. So what do you do now? You can do a couple of things. You could bring that sine cosine up. You could rewrite the tan and the cotan. I don't know what that'll do. Tangent is equal to sine over what? Sine t over cosine t. I don't know if that's going to help, but let's see. Sine t cosine t minus cosine t over the sine of t sine cosine. Work with it and see what you can come up with. I'll figure out why it's going like this bonkers. It gets in a certain mode. Okay, well, I'll just leave it on the node that I'm on, because evidently it won't switch between nodes. Now, on this, you can pull this out. You can pull this guy out to the front. You can pull this guy out to the front. Now gives you sine t of cosine t times 1 over sine t cosine t minus cosine t over sine t times 1 over sine t cosine t. Yes. I'm sorry, I can't hear you. Well, you can do that. What's this over? 1. What's this over? 1. So I'm going to divide sine t of cosine t by sine of this. What do you end up doing? You bring this up, and you what? You flip it. No matter how you do it, you're going to get the same thing. And what happens to the sine of t? What happens to cosine of t? When you're left with 1 over cosine squared t minus 1 over sine squared t. And what's 1 over the cosine? Secant, right? So 1 over cosine, I'll go over here. 1 over cosine squared t minus 1 over sine squared t. What's 1 over the cosine is what? Secant squared t. And 1 over the sine is what? Cosecant. No. Cosecant squared t. What's on the right hand side? Of course it is. Now go the other direction. Take the other side and see if you can go the other direction. You might be able to if it's not too complicated.
Well, we just multiply both sides by sine t cosine t. The secant squared, you get to, the cosine squared, then multiply opposite by 1.
Well, you get this right here and you go backwards. Yeah. Is that what you're saying?
Yeah.
Yeah, you could do that. You get this, and then you get a common denominator. Yeah. You'd end up going backwards, yeah. You could just do it that way. So, if you went backwards, it would be going this way right here. And then you get a common denominator. Yeah, it would work out. Okay, so again, it's just manipulation and rewriting. Let's do a nerd. Oh, there's the answer. If you can see it. Hold on. There we go. Here, they brought the tangent out first, and then they changed it to sine over cosine. Doesn't matter, you do what you want. Tangent over 1 over sine cosine over 1 comes out to be this right here. And then I rewrote the tangent first and then did it. So however you want to do it. All right? I still don't understand why it won't do what it's supposed to do. It's supposed to flip back and forth. Huh. And it still didn't do it, did it? All right, pick on the left-hand side, because the left-hand side is, you might be thinking to yourself, okay, I can rewrite that as far as sine over cosine, as far as 1 over the cosine, so I might want to deal with this. I have no idea. So the American history teacher hadn't been talking about the election. I find that odd. I thought it was all about Hillary. Maybe her deplorable statement about falling down on the sidewalk, maybe he's kind of taking those back a little bit.
Well, when you were talking about history, you have to be able to do it
No! English teacher. I wasn't firing shots at anybody. You can go to communications. I don't know. I'm not an English person, so I don't know. You'd have to ask the English teacher that. An English teacher can tell you. I'm sorry, what? Yeah, you go into publishing, editing, be an editor for a newspaper. Write for the Clinton News Network. I'm sorry, CNN. Huh? Yeah. You could influence a lot of people, Mr. Smith, if you go into journalism. You could influence people. What? I think you ought to go into journalism. That way you can set a lot of people straight. You might be like the Donald Trump in the you'd be the Donald Trump in the editing world.
I've been writing about all the atrocities committed in the Middle East.
Oh no, the Middle East, everything's fine.
You know that right now they have
everything's fine. They love women. They love the gay and lesbian community. They love Christians.
You know, it's like they've enslaved over 14 million. There's 14 million.
No, you're a propagandist. You're lying.
Did you see that article about what they did with the slaves?
No, you're lying. You're lying. The Middle East is heaven. The Middle East is heaven. You always takes money from all those people. No, I have no idea. What is the secant? 1 over the what?
Cosine.
So 1 over the cosine, and I'm going to forget alpha. Alpha's right there, okay? Plus tangent is sine over cosine.
Didn't you do
over right now? I'm working right now, okay? 1 over the cosine minus sine over cosine. Oh my gosh, we've got a complex rational expression. So now we can multiply by the common denominator over itself. Let's see what we get. Or we could go ahead and do 1 plus sine over cosine, 1 minus sine over cosine. I don't know. Let's do that. 1 plus sine over cosine over 1 minus sine over the cosine. Oh my, I'm dividing a fraction by another fraction. So I can multiply by the what? I have no idea what's going to happen. Cosine of whatever over 1 minus sine. Cosines cancel. And you're left with 1 plus the sine over 1 minus the sine. You know what? I could really use the conjugate right now, because if I multiply by 1 plus the sine, over 1 plus the sine, what will that give me on the bottom? Shortcut number 3, Hubert. That's right, class. Then we'll have shortcut number 1 on the top. So, shortcut number 1 on the top, I believe, and shortcut number 3 on the bottom. Go ahead and finish it. 1 squared plus 2 sine theta plus sine squared theta over 1 minus sine squared theta, which is cosine squared. Shortcut number 1 and number 2, 3. What is A? Okay, let me go over the algebra again for the 5th time. A plus B times A plus B is A plus B quantity squared, right? And A plus B quantity squared, I'm going to rewrite it right here. A plus B quantity squared is equal to what? No, quit talking. What is A plus B quantity squared?
A squared plus
A squared plus 2AB plus B squared. Now let's go over shortcut number 3. A minus B times A plus B. A minus B times A plus B is equal to what? A squared minus B squared. So, I've got this right here. And I've got this right here. So, I need to write this like this, and this like this. Let's see what you get. If you're sitting there right now, and you're going, shortcut number 1, shortcut number 3, you're in trouble. I don't know who it is. Don't raise your hand and say, you're talking about me. If you are saying, starfish, package starfish, you're in trouble. So that means you need to quit the class or you need to go back and run those shortcuts. Quit the class. It's easier. Learn the shortcuts. If you don't, then you're going to what? Live in a ditch. Yep. So, what do we got? Somebody tell me what we got on the bottom. 1 minus sine squared theta. What do we have on the top? Okay, this is the bottom right here. 1. What is A? I'm asking, what is A? A is 1. So take that 1 and put it right here. 1 squared is 1. What is B? B is the sine. B squared. Now we're going to do the same thing with the top, except we go the opposite way because that's shortcut number 1. A is what? 1. So that means 1 squared. I'll have to write it like this right now. 1 squared plus 2 times 1, and then what's B? Sine. I'll write it in black in just a minute. Plus, what is B squared? Sine squared theta. And then I'll take my black pen. 1 squared plus 2 times 1 times sine theta plus sine squared theta. And 2 times 1 is 2. Looks like I got that. But what's 1 minus sine squared? Yeah. Out of all the chapters in trig, there's four units. This one, for those that are going to calculus, this one is the most important. You can suck at all the other three, but if you know this one, you can make it through calculus as far as identity. Now, I'm not talking about calculus 1, I'm talking about all of them. Because these identities creep up on you in every single one, all the way up to DPQ. They come in like the shortcuts. The way the shortcuts are coming in on you on trig, the shortcuts and the identities are going to come into you in calculus. They're going to creep up. Every now and then you'll be going along, and boom, you'll be sine squared plus cosine squared, and then you'll be going. And you got to know them. So out of all the units that we're going over, this one's probably the most applicable to all of the trig. I mean, all of the calculuses and DPQ. So, and the algebra that you learned last semester in 110 is detrimental. That problem that y'all saw a while ago, and you asked Mr. Smith, you asked if it was one problem, the calculus problem that came up on the board. 90% of it was algebra. 10% of it was calculus. The first two steps was calculus. The rest of it was algebra. So if you suck at algebra and the identities, then you're going to what? You're going to fail calculus. So just going to go ahead and tell you that. Just want to give you some encouragement. There's the answer. Make sure we did it right. Did we do it right? I can't remember what we did. Okay, they changed secant plus tangent. What did they do? They multiplied by cosine on both sides. That's fine. What did we do? We rewrote it, didn't we? Yeah. Now, this is a prime example of, can you do it different ways? Yes. As long as you don't make that, as long as you don't like erase something and change it into something that it's not. You can't do that. Capiche?
Yep.
Okay, that's not supposed to be there. Huh? Oh, it's the same problem. Daggone. They're still doing that problem. Is that the answer? There's the answer. I'm sorry. I didn't know what they were doing. I'm sorry. Okay. I'm not worried about this right now. All right. Now let's look at the next one. What time's class over? I thought it was 12:30. Okay, let me go into the next section. Hold on just a second. I got to find it. There it is. And that's 9.2. Not going to go over all of it. Just going to start it. Right now, you're responsible for 9.1 homework. Those last couple of problems we did, that's test questions. I don't care about anything else. I want you to be able to manipulate and be able to go from one to the other. Black or unblack slideshow. See all slides. I see a little red dot. Nope. We're in training right now. It's not going to do it on the display. I have to switch it to a different screen. I'm learning. Just leave me alone. Well, that sucks. I'm going to figure out how to do it before it's over with. All right, sum and difference identities. Now this is all nice and pretty, and if you want to rack your brain with all of this, then knock yourself out. But basically what you're going to be learning is this right here. So you need to write that down. The cosine of A minus B. These problems are real, these identities are real easy to remember because it's always the opposite. Cosine of A minus B is equal to the, and remember, the cosine and the sine, they have their differences, but most of the time they like to stay together. So cosine goes with A and B, and then the sine, they go with A and B. The sine is going to be the opposite. So the cosine of A minus B is going to be equal to blah, 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 plus blah, blah, blah. So right down the bottom part, I was hoping they would do it all at one time and show all of them. That's the way I show them. There. Now, the easiest way to write this is like this, not like this. The cosine of A plus or minus B is equal to cosine of A cosine of B minus the plus the sine of A sine of B. That's the easiest way to write it. So if you have A plus B, what's the primary operation going to be on the right? Minus. If you have A minus B, what's the primary operation on the right? Plus. It's always the opposite. Now what does that mean? Well, you're going to use these when you have an angle like I'm thinking 75 degrees. What's the cosine of 75 degrees? I have no idea. We'll use my calculator. No, you know the cosine of 45 plus the cosine of what? 30. And you rewrite it. Cosine of 45 plus 30 is equal to the cosine of 45, the cosine of 30, minus the sine of cosine, the sine of 45 and the sine of 30. So that's how you would use this. I don't know what they're going to give us. We're going to do one right now. So let me change this back. What? No. What? So example. Cosine of 75 degrees. Now, cosine of 75 degrees is going to be cosine of 45 plus what? 30, that's how much it is. So that's equal to cosine of 45 times cosine of 30 minus the sine of 45 times sine of 30. Now I want you to do that, and the reason you can do it is because you remember your what? And what? The 30. bring on sine is equal to Oscar had. So cosine is equal to a hump. So that's going to be 1 over square root 2. And 1, cosine of 30 is square root of 3 over 2. Minus the sine of 45 is 1 over the square root 2. And that would be 1 over 2. Y'all check me. Now, finish it. Now, I don't want you to use your calculator. You don't need your calculator yet. I want you to get it simplified as much as you can. Yeah, rationalize, do everything you know to do to get it down to something simple to put in your calculator. Which they're not going to want that. They're going to want you. In mathematics, the perfect, not perfect. What's the opposite of approximate? I call it something in the homework and the test. I call it not perfect answers. Exact. The exact answer is radical. Exact means radical. Approximate means put the radical in your calculator. Yeah. I think anything really stood out. What? Yeah, but at least they were playing a college team. I think South Carolina played Spartanburg, and I think Clemson plays Daniel. So, the best game this weekend was Alabama and I didn't see that. I didn't see that.
Michigan State. I watched North Dakota
I'm
State.
sorry,
I was
Michigan State. I'm sorry.
I was pretty happy that Army beat
Don't feel about that. I'm sorry.
Hey, Army.
Why don't they have a Marine Corps football team?
Well, let's do it.
I mean, I think they should have a Marine Corps football team. I think it was pretty much domination.
The only player is Army.
Yep. Right up the middle.
Especially they run it up the middle or on the side, sometimes they throw it.
Okay, so we're not going to talk about that. Who does Georgia play this weekend? No, they played Missouri. Who does South Carolina play? No, it's Cupcake. Cupcake week is over. I think the first couple of weeks. South Carolina plays Kentucky. That could be a game. It could be a game of losers.
Oh, Thursday.
And then they have Louisville on home next week.
They will lose against Louisville. That guy in Louisville is just.
Well, what about Louisville? Louisville's defense?
I don't know, but I know that one guy for Louisville, he just walks all over people. Who does Georgia play? Please don't say that bad one.
No, they don't play Alabama.
Oh yeah, that's right. They're different conference.
Georgia plays Ole Miss. At Ole Miss.
I wanna watch that
At Ole
game.
Miss.
I wanna see
And
that.
then they have Tennessee at home. Then they're at South Carolina.
Who does Alabama have? See who Alabama has.
They have Penn State.
Might as well be Daniel High School.
Yeah.
All right, so we've got the square root of 3. Well, let's go ahead and take this and make it square root of 2 over 2. And times the square root of 3 over 2 minus square root of 2 over 2 times 1 over 2, right? So that's going to be the square root of 6 over 4 minus the square root of 2 over 4. Everybody with me? So the square root of 6 minus the square root of 2 over 4. You can't take away, you can't do that. The square root of 6 is, let's see, square root of 3 is 9. 4 is 2, or 2 is 4. So 4 to 5, half of 4, half of 2.5 is 2.5, is 6.5 is equal to 2.5. So that's going to be 2.4 minus 1.4 over 4. This is your answer. But as far as calculator answer, 2.4 minus 1 point, but that's going to be plus or minus. So that's going to be 2.4 minus 1.4 is 1. So that's 1/4. So 0.25 is going to be close to 1 answer. And negative 2.4 is negative 3.4. And that's going to be around negative 0.8, somewhere around there. So when you do those, you'll get probably 0.25 and around negative 0.8. But I don't care about that. That should be your answer. All right. That's good enough for government work. Let's go ahead and take the roll right quick.